Hi, this is Paul again. I've got another new video to show you, and I'm calling this Chico Chica Ocho 3D integrated geometric order. In the last few years, I've put a lot of research into geometric order, three-dimensional geometric order. So first of all, I'm going to start by showing you two cubes, the Bucky cube and the Plato cube. This is a discovery I made in 2009, and I called it CubicWONDER. I guess academics were focused on the theory of chaos, and they never took any interest in any of this three-dimensional order. I originally described this CubicWONDER as a children's toy, geometric toy. Now each cube is basically made up of 8 smaller cubes. I call them Chico Chica, is the same as male or female. Now the Chico cube and the Chica cube both have 5 pieces. So let's take a look at this. We'll start with the cube's outline. And now I'm going to bring in one Chico cube, which has 5 pieces. Okay, now I'm going to bring in the Chica cube, and this has 5 pieces also. Now notice the Chico is the green corner, and the Chica's got the white corner. Now there's something important to remember. The Chico never goes together with a Chico, and a Chica doesn't go together with a Chica. They're always opposite. So a white always goes together with the green. Okay, it takes 8 of these little cubes to fill the Plato cube and 8 to fill the Bucky cube. Let's take a look. Okay, it fills the Plato cube first, and then it fills the Bucky cube. Isn't that something? I'll put this little anim in reverse, and then we'll put it forward again. Isn't that something? I guess this little toy shows more three-dimensional order than 60 years of chaos theory. Anyways, let's get back to Chico Chica. I got something else to show you. Now look how these 3 Chico Chicas are arranged in a cube. Now the green and white corners of the Chico and Chica meet at the center of the Plato cube. But they're the corners of the Bucky cube, they're the opposite. I think this is a very important discovery. In my last videos, I was working on quad step rings of 4 colored balls, and this was matching up perfectly with this CubicWONDER. So I'm going to show you in this next clip the colors of these balls for these intersections. So now you can see I show a red ball, and this goes in the center of the Plato cube. Now you can see that this red ball is the center of the white octopiece and the green octopiece. Now 8 of these octopieces will make up an octahedron, and I show the outline in yellow. Okay, now I'm going to show you a full Bucky cube. Now it's plain to see that this geometry can be repeated on the 8 corners of the Bucky cube. Now what it's really showing is an octahedron, and a cube octahedron can be used for close packing in space. Now the cube octahedron and the octahedron was shown as close packing by Keith Critchlow in his book Order in Space. But I guess a lot of his wonderful work was given the cold shoulder by the two-dimensional mathematical know-it-alls. Okay, let's move on a bit, and I got something else to show you. Now the advantage of using this 40-piece system of CubicWONDER is that I can select the red, blue and cyan colours and remove them. Okay, we'll start with a full Bucky and Play-Doh cube. Now for this little demo, we don't need the cyan, blue or red anymore, so I'm going to delete them. So look what we've come up with. Now in the top cube, the Play-Doh cube, we show the Star of David. Now integrated in the center of the Star of David, we have the green and white octahedron. We need to keep this, but we don't need the corner pieces on the Bucky cube, so we'll just hide them 8 pieces. Now we can see that we've got the Star of David in the Play-Doh cube and the vector equilibrium in the Bucky cube. Okay, now I'm going to hide the purple color. And now we can see that we have the yellow pyramid and the faces of the green and white octahedron, the greens are showing. Okay, let's unhide the purple again. And now we'll hide the yellow. And now you can see that the purple pyramid shows the face of the white octahedron. So now we'll unhide the yellow again and we're back to the duo. So now we can give the complete duo assembly a little rotation. I think a lot more research needs to be done on this wonderful system, because I think this is the foundational geometry for bonding and the 118 elements. I've showed in my earlier videos this. People working in chemistry can come up with bonding geometry and stuff like that, and then the other academics are teaching that everything is chaos and the bifurcation and all this stuff. And nobody's showing this 3D geometric order, and nobody's taken any interest. I've had a lot of insults from mathematicians because of my work, because they were bragging that they can take chaos into the 8th dimension. That's very useful. Anyways, let's get back to Chico Chica. I've got something else to show you. In the last couple of years, I made the discovery of a system I call quad step. It's 4 colored balls. Now you can see in front that I'm showing a 3 and 4 fold system of quad step, and it fits perfect to the triangles of this system I'm showing you. Now you can see that this 3-dimensional geometry is fitting perfectly to the centers of the balls on the rings. This is a major discovery. But I guess by 1 or 2 views I get from around the world, it shows that academics are not showing one bit of interest in this major discovery. I guess this is what you call academic supremacy. Anyways, what can you do about it? Let's take a look at this in the top view. I think this needs a young whiz kid that is good at chemicals and stuff like that and bonding, and start doing research with this system. I think the days of these 2-dimensional theorists that want to control everything are coming to an end, because 3-dimensional work is very, very important. Anyways, I've got something for the children coming out of this. So what they have to do is to take the Chico and Chica Cubes out of the Bucky cube and put them in the Play-Doh cube in the correct order, and then vice versa. I think this is a good test for children to see their aptitude for 3-dimensional work. I think some people are very good at remembering equations and stuff like that, but when it comes to 3-dimensional practicality, they're not so good. I think there's been too much of this I'm better than you type of thing that's going on in the world. It causes a lot of problems. Anyways, I think I've showed enough 3-dimensional order for today. So this is Paul saying thank you very much for watching my video.